All right, everyone, welcome to the areas of triangles. So we're going to talk about a couple different ways we can find areas of triangles, whether they're oblique, it's just with an angle of 90 degrees, or a special case for area with Heron's formula. So to find the area of an oblique triangle, we can use one of the following expressions. They're all derived from the law of sines, and they're all equivalent. So area equals 1/2 b times c times sine of the angle. Or you can use 1/2 AB sine of C or 1/2 AC sine of B. It all depends on how the triangle is labeled and again what is given, whether you have sides B and C and angle A. So it all just depends on what you're given and which formula you can use. They all will get you the area of a triangle with an oblique triangle, but you just have to be careful on what is given in the problem. Okay, if you have an angle of 90 degrees, you can just use area equals 1/2 BC base times the height. Okay, so we're going to do an example where we have to use one of these three definitions. Okay, so first, find the area of the triangular region having two side lengths of 90 meters and 52 meters respectively, and the included angle of 102 degrees. Okay, so I just chose A equals 1/2 AB sine of C. I let A equal 90 meters and let B equal 52 meters. A, B, and then I called this angle C. They didn't give me any specific names, so I just chose what I wanted to be. I could have used any of the three formulas, didn't matter. So I write my formula for area, and I write 1/2. So after I write the formula, I substitute my known values: 90 for A, 52 meters for B, and 102 degrees for the angle. And so I just go ahead and plug and chug. 1/2 of 90 times 52 times sine of 102 degrees, and I get an approximate area of 2,289 meters squared. So there's not much to this. It's just identifying the sides and the angle, plugging it in, and simplifying. Okay? Now, another type of area we can find is from a Greek, I believe he's Greek, mathematician named Heron. Okay, some textbooks actually call him Hero. I think our Blitzer textbook calls him Hero. It's Heron's formula, and it's for the area of a triangle. And here's his area. It is equal to the square root of S times the quantity S minus A times the quantity S minus B times the quantity of S minus C. Important things to know. A, B, and C are side lengths of the triangle, and S is equivalent to the quantity A plus B plus C, that quantity all divided by 2. So in order to use Heron's formula, you have to know all three sides of the triangle. If you don't, you can't use it. So here's an example using Heron's formula. Find the area of a triangular region having sides of A equals 43, B equals 53, and C equals 72 meters respectively. So part one, I want to find S. So I write my expression for S, and I plug in A, B, and C. I add them together, and I divide by 2, and I get 84. Step 2 is now apply the formula. I have S, I know A, I know B, and I know C. So I write the formula here for area, and I substitute all my known values. 84 for S, here, here, and here, and A at 43, B at 53, and C at 72. So here you see those differences written. And so I get 84 times 41, which is the difference of 84 and 43, times 31, which is the difference of 84 and 53, times 12, which is the difference of 84 and 72. When I multiply all that out and take the square root of that, I get approximately 1,131.890 meters squared. Okay, so that's the area using Heron's formula. The last little bit just kind of summarizes what you need or what we've done with area in this video and in general. The standard form for area of a triangle is area equals 1/2 the base times the height. When we speak about oblique triangles and finding the area, we can use one of those three forms that are derived from the law of sines. Heron's formula is another way we can find the area. It's kind of associated with the law of cosines because law of cosines is used when you know all three sides. Heron's formula to find the area, you need to know all three sides of that triangle. So this is just a summary of the types of areas we've talked about and used. So if you have any questions or comments, let me know. You can type them below, and we'll see you next time.